Hi everyone, Tassone here from Sama Learning, and I just wanted to take a few times while we're all locked inside our houses to talk about why virtual reality is so important for teaching STEM. And I want to start with one of the biggest organizers of information content that we have as chemists, the periodic table. And we spend a lot of time teaching students how this organizes so much information. But in virtual reality, we don't need to just tell students that is the case. We can show students that's the case. So one of the first things you learn in the periodic trends lesson is the trend in periodic size. So as I clicked on boron, I can see the quantum mechanical orbitals for boron show up right in front of me. P orbitals, the S orbitals are buried inside. And instead of telling students, believe me, the trend is atoms get smaller as we move from left to right across a period, I don't need them to trust me. They can look at how fluorine is. Sorry, I'll rescale boron back to 100% actually. Easier way to grab it again. I don't need to ask them to trust me. They can see. This is fluorine, this is boron, significantly smaller than boron. And we can look at intermediate cases just as easily. So let's look at nitrogen and see how it fits in the mix. And so just in 30 seconds right now, I have done more to reinforce the fact that atoms get smaller as we move across a period than a 20-minute lecture would have done. And this is really the power of VR, is putting a shared mental picture in all of your students' hands, making the abstract connection between this box on a periodic table and the size of the atom tangible, and then giving students an environment to explore those connections and ignite that excitement that we all felt when we first started learning chemistry. So I hope you'll go check out the freely available set of Sama courseware at samalearning.net. Please take this time while you're out of the classroom to see how VR can help improve your instruction for your students. Thank you so much. Bye.